My name is Dave Smith. I'm with Interstates. It's kind of a funny story here. You know, Jeff, I signed up and registered for the conference, and I think no less than 5 minutes later, Jeff is pinging me, "Hey, are you coming in person, right? If so, do you want to talk?" And I'm like, "Oh, I don't know about that, Jeff, right? But I guess you could twist my arm, right?" But then he told me, like, you can have 30 minutes or 45 minutes, right? And I said, "Well, I just need 30 minutes. I don't need to talk that long." Well, he's like, "I'm going to give you 45 minutes, and if you finish early, everybody can go to lunch early, and everybody will be happy." So hopefully we finish on time, finish early, and we can go to lunch and be happy.
If we're behind, that'll help us catch up.
So like I said,
I'm playing a video later, Dave.
What's that?
I'm playing a video up there later.
Jeff and I do go back a little ways and have had some fun conversations and stories in the past few years, that's for sure. So I'm going to talk a little bit about ICS Defender and a little bit of a customer use case that we have. I'm going to talk a little bit about Interstates just real quickly so you can understand what our background is and how we relate here. And then I'm probably just going to go sit down because Josh already stole all my DPI stuff, so I might as well just quit. So hopefully my goal is to show you a little bit of the DPI stuff, and again, hopefully mine goes a little bit better than Josh's, but we'll see. So like I said, my name is Dave Smith. I've been with Interstates here for 7 years this summer now. I do a lot of work in our OTIS group, so Operational Technology, Infrastructure, and Security. I do a lot of work with virtualization platforms, networking, security, kind of all of that stuff, right? So Interstates, we're a systems integrator, and we do a lot of stuff in value-added ag, a lot of stuff in consumer product goods. And so we do a lot of stuff in North America. We also do stuff around the world. We have a remote office over in Germany, so we have kind of employees spread all over the place. Again, I kind of touched on this a little bit, some of the markets that we serve. So you can see that there. What does Interstates do? We do a lot of consulting, industrial automation. We do temp power skids, electrical engineering, construction. And so really anything in the OT networks, the OT space, from electrical pipe and wire all the way to automation and security, Interstates kind of covers. Where I focus again in operational technology, like I said, we do a lot of endpoint security, cybersecurity, virtualization, and networking. And so what I really want to talk about today is ICS Defender. So you guys saw a little bit of ICS Defender from Josh. We've done some work with some customers around ICS Defender in different scenarios, different use cases. I want to touch on one that we kind of did using DPI specifically, kind of what the need for DPI was and how ICS Defender really brought the additional value that the customer couldn't get from just the traditional firewall. So a little bit of history, right? We worked with a large CPG company doing ICS Defenders. A lot of work on edge hardware. So we were using some of these Dynics edge gateways here, running ICS Defender as a virtual machine actually on that hardware, so that they could kind of do some different microservices, right? We probably did it. Those installations were probably different than probably 95% of installations you would see with ICS Defender. So actually what we were doing in those installations is we would run ICS Defender as basically a pure layer 2 device. So we would do a layer 2 bridge across 2 interfaces, and we would use that to basically control traffic from an area or a location on the plant floor. And so some of the reasons for that were the customer really didn't want to go and re-IP all of their devices, right? Or change subnets or change VLANs and all of that work. They wanted to keep their VLAN that they had flat and add security to that, right? And so with ICS Defender, you can make a layer 2 bridge. You can add specific rules to control and basically isolate a cell or a zone or a process, however you want to look at that, right? And so we were doing a lot of work in that space, right? More of kind of the edge computing side of things. And because of that work, we were brought into another use case because of some of the features that ICS Defender had. And so this use case was, this was a company over in Europe or Germany, I believe. And they basically had a manufacturing facility, and they had a third-party bottling company that was on site, right? And this bottling company would provide the bottles for them to make their product, right? And they had to do inventory back and forth so that they made sure that they had enough product to supply. The techs on the line had to make sure that they had enough bottles in inventory so that when they started a production run that they would be able to support that. And so when we came in, the current state was they would do that manually. It was tracked on paper, or they would make a phone call to the vendor and say, hey, how many bottles do you got? We got a production run coming of 500 bottles. We need to make sure we have them in inventory. Or they would go and log into the PLC or the HMI locally on the line and take an inventory of how many bottles were in inventory. And what they really wanted to do was make that process automated, right? They didn't want to depend on somebody calling or somebody, communication like that between each other, right? And so essentially this, this high-level drawing at the bottom here kind of shows how that was, right? Basically they had their manufacturing site with your traditional manufacturing networks, right? They had a corporate firewall. This specific customer actually had an industrial firewall as well, isolating their manufacturing zone from their IT zones. And then they had, a Rockwell PLC skid on the line. On the other side, the third party also had a PLC skid. I did not show all of their networking, but typically they would have the same networking on their side as well. And so, like I said, the goal for that was really to stop manual communication between the two, right? And so they wanted to be able to do better real-time inventory. And essentially, the initial take that the site and the site engineers wanted to do is they were literally going to take a cable and plug it from their PLC skid into the third party's PLC skid, right? They were going to make a direct connection, Well, that works, right? It's simple, it's easy. They get their inventory. It doesn't require a lot of effort from anybody. It doesn't require any firewall work. But of course, as you can imagine, that bypasses all of corporate security and all of best practices, right? So they were then bypassing the ICS firewall, they were bypassing the IT firewall, and they were just making a direct connection to a third party who they really didn't have any control over, right? They were basically allowing their network out. The other side of that is that also still allowed that third party to have complete access to their PLC, right? Read, write, anything, any tags on that control network, they could see once they had that direct connection. And that was really one of the desires that the customer had, is they wanted to prevent that. They wanted to only allow the third party to read the bottle inventory in the skid, right? They did not want them to have any ability to write values back into the PLC. And if they did, it was very select values, right? Maybe they would write back a value that said, here's how many bottles that I have on hand, right? But not control any of the values that controlled the actual production line. And so that was a big priority for them. Of course, they also wanted to reduce visibility to all of the other tags that were in the PLC. That's just a duplicated drawing, it looks like. And so this is kind of when we were brought in as a systems integrator. And essentially they started talking to us, started expressing the use case, say, hey, you guys have had some experience with ICS360.Defender. What can we do with the DPI? How can we make that fit our solution? What are our options? And so, prior to coming with the ICS360.Defender solution, they also came up with another solution that would have given them better security than they had before, but not completely what they wanted. And so their second solution that they came up with was, well, we'll just connect the chassis, the PLC chassis, to the ICS firewall. And we'll do rules on our ICS firewall, and we'll protect it that way. And that is a much better solution than the first one, right? Because now they are not bypassing corporate security policies. They still get their inventory. But essentially they still don't get their third-party access control like they wanted to, right? They are able to now doing this. In this case, their existing firewalls were Cisco firewalls. And so they could do Cisco firepower technology on the firewalls where they could do DPI, or sorry, not DPI, IDS or IPS, where they could do some intrusion protection on that packets going across. But the Cisco firepower could not get to the PLC tag layer that they wanted to, right? And so it was very high level still. And so they kind of said, you know, this is a good solution, but it's maybe not where we want to be yet. And so really what they came back to then is the end solution was, hey, let's install an ICS basically below your corporate firewall. And so what they did is, as before, the third party connected their chassis to the ICS firewall on a dedicated interface so that they could communicate, right? And then they utilized their existing network connections to basically put the ICS Defender beside their connections. Then what they did is they forced the traffic to go through the ICS firewall. And so all traffic through the ICS Defender firewall. So all traffic had to flow through that firewall. And then simply they could start writing DPI rules to say, you can only write or read these specific PLC tags. And so this was really the best of all worlds for them, right? They retained their corporate security policies where the corporate could see any of the traffic going through their firewall, right? They could still do IPS and IDS on that traffic from a corporate security standpoint, but then they also got the deep packet inspection that the ICS Defender added to that layer. And so they really started to do their defense in depths where they could have multiple layers of security here. And one of the things that they did do is because the site is fully redundant in all their connections, they actually ended up running a pair of ICS Defenders in HA mode so that if one of them failed, the communication would automatically take over. Because this was kind of a process critical communication for them. If they didn't have the inventory data, they wouldn't be able to run their line or be confident that they wouldn't run out of bottles. And so really what that looks like is I have a couple slides here, but I think I'm going to attempt to show you kind of what that looks like in the ICS Defender itself. And so this is an instance in our lab, and so it doesn't have actually any traffic going through it or devices connected to it. But I just kind of wanted to give an overview of what the interface looks like, how it works for a user, and kind of how simple it is. And so really, when you have the Pro license, you can start to get to this industrial protocols here, right? And there's a few different things. You have profiles, rule sets, rules, analysis, etc. And so the first thing that happens is you have to understand what is your traffic or what are your tags that you're trying to apply these rules to, right? ICS Defender allows you to basically ingest or capture a PCAP of that file. So you can capture a PCAP inline from ICS Defender, or you can use a tool like Wireshark to capture that. And so I have basically a Wireshark PCAP here. And you can see basically here's all the SIP traffic that's occurring in this example, right? And what you can do is you can feed that into ICS Defender, into their analysis. You just upload your PCAP file and you can start to see here all of the different examples of the different tags and the different layers that you can start building rules on. And so really you just start to look for what is the function that I want, right? So in a lot of cases, this could be a read function, right? So you can start to look for some of your read services. If you were looking for write services, you would select those. And then from there, you start to build out different rules. And so if I go back into there and I go back to my rules, you can start to see here an example of some of the SIP rules that I pulled out of that PCAP and put into the UI here. And so there's different read or write services that are displayed here. And then what you do is you take those rules and you can bundle them into a rule set. And so a rule set is basically a group of rules. And so if I would look at this read rule, you can see here it's a bundle of rules, right? And so it makes it a little simpler from that perspective. And then from that rule set, you can add that rule to a profile. And a profile is really just how those rules interact, and a profile is what you would pull into your firewall rules then as well. So if I go to this profile of allow read tags, you can see here that the default action is block, right? So anything that doesn't match the rules that are below here in my profile is going to be blocked. But because I have this rule set in here, and you can do individual rules too if you wanted to, but based on this rule set, anything that hits here will be allowed. The next step really is to build your firewall rules. And this is a little bit where some of the enhancements that Josh was talking about come into play. But if I go to my firewall rules here now, I can see that basically I have a rule here that shows I'm going to allow this source to this destination, and you can see the industrial protocol that it's being applied to. And it's very simple to create a new rule as well. It's just like creating a new firewall rule. Except for in the action section, instead of selecting pass, you would select industrial profile.
Used to be protocol, we changed it.
Changed it on me, huh? And then, as you can see here are my profiles that I built in the other screen, right? So I have the two profiles. You simply assign a profile, and then you have the rest of your traditional firewall rules that you can do. And what this does is as soon as traffic hits that rule profile, it'll send it to the DPI engine. The DPI engine will analyze that traffic automatically and say, here's the rules and the tags and parameters that need to be applied. I guess any questions at this point?
Was there a lot of work on the tag base for reconfiguration to meet these rules and protocols from a plant floor level?
I would say there was no work from the plant floor work, right? Because we're literally just capturing what they're doing today. And the work is really to analyze what the traffic is, and to be able to, if I look here, I think the real work is looking at this list of all of the traffic that was seen and identifying pulling the specific packets out that you actually need, right? And understanding which program, which protocol, which tag do you actually have to read, and only get that one.
So I was wondering, okay, so from a read standpoint tag, but from a write standpoint, there was nothing either to concern on that traffic for writing to tags?
Yeah, and so what we did is, obviously, I think they have changed it since, I don't remember for sure, but when we initially implied it, it was read-only, and so because it was read-only, we blocked all write communication. So essentially anything, now that's only communication that matches that firewall rule, right? So if you're writing from a different source or your engineering workstation or whatever, that's not effective, right? Because it's only the rules that are coming from the specific source to destination that are going through the firewall, right? That get analyzed. And because of in the rule sets, right? When you build out your rule of profile, because here you're saying by default block everything other than maybe these four rules that I want to say read, blocking that write becomes pretty easy in that standpoint, right? You can basically add a manual rule as well, right? If you don't want to go through, if you don't have a PCAP or you don't have that data, and you know exactly what program, what protocol, what tag, where you're looking for, you can actually add a manual rule here and add all the specific details as well. There are a few, basically generic profiles, right? So you can set some of these profiles automatically, blocking a get attributes all, or a stop or start, there is, general SIP data read, data write. So you can do some of those generic profiles. If you don't want to do it tag based, right, you can do it a little bit broader than that as well. Oh gosh. You can get rid of that.
I just not sharing, Dave.
So this is an SDN video that we did, and Jeff decided this is why your updates to your products are slow, because Jeff does stuff like this in the background, right? He has obviously a lot of spare time.
Yeah, I think
the Snoop poster on the door. I got the angle to next to the door was like, took me an hour.
So yeah, we've found, a lot of different use cases for ICS Defender, whether it be, running on Dynics hardware, we've done a lot of instances where we're actually running it as a virtual platform, where we're running it either on our own hardware, somebody else's hardware, even Dynics's hardware, virtual stacks, right? Running the virtual version of ICS Defender is also something that we've seen a lot of use cases for. And just the flexibility to be able to do that across different platforms has been really key for us.